All right, we should be live. Can someone in the chat let me know if they can hear me? It should be on. Are you guys seeing this right now? You guys seeing this? Anybody? Anybody in the chat? Okay, sorry. I am, like I did in the last one, I'm still kind of getting a little bit used to this, so just making sure you guys can hear me. Sweet. All right, so my latest video that I did, I had a lot of feedback on it, and I just figured it'd be a little bit easier to kind of go ahead and address some of this feedback inside here. Be patient with me because it's difficult for me to focus on what I'm going to talk about and pay attention to the chat at the same time. So I'm going to, kind of look over at it as much as possible. What I want to really talk about here is the headmaster operation and what the purpose of the headmaster is and why we have it in the system. Okay. You may hear me refer to it as a headmaster or a head pressure control valve, a low ambient control. Those are all the different things you guys are going to hear. Headmaster is just kind of, I think that's actually an actual name, a product name, I think is what it is. Okay. But it's kind of just the default that everybody kind of refers to him as a headmaster. Okay. So the purpose of a headmaster is to maintain a certain pressure drop across your thermostatic expansion valve. Okay, you may not have heard it explained that way before, but that's the true purpose. Okay, your thermostatic expansion valve is a valve that changes the state of the refrigerant, as we know, from a liquid to a liquid vapor mix. Okay, going into your evaporator coil, and that thermostatic expansion valve does not work well if it is not within a certain uh, parameters in the system have to be perfect, okay? Meaning that we have to have a certain pressure drop or pressure differential across that thermostatic expansion valve or TXV, okay? In the system, we have a problem though, okay, is that, and we're talking about commercial refrigeration systems and some air conditioning systems, okay? You will see a headmaster valve on an ice machine also, all right? It's whenever we have a condensing unit that's located outside in the outdoors where it gets below typically 70 degrees for a long period of time, that's when we start to notice refrigerant problems at your expansion valve. Okay, we'd start to see issues, you start to see bubbles forming inside your liquid line. You'll see them in your sight glass when the outdoor air temperature drops too low, essentially. Okay. So our headmaster is simply there to raise the head pressure in the system, okay, and help us to keep the pressure at a certain level, okay, to help to maintain that pressure differential across that thermostatic expansion valve that's downstairs at the evaporator coil, okay. What'll happen is if we took a refrigerant, I don't have a pressure chart on me right now, but we already know, right, that refrigerant is a certain temperature at a certain pressure, or vice versa, a certain pressure at a certain temperature. Okay, either way. So with that being said, we know that when the ambient temperature at outside drops below, let's just say 70 degrees, we know that our 404A refrigerant is going to be this pressure at 70 degrees. Okay. So what we can do is we typically don't do this, but what you'll find is that a headmaster has been installed inside the system. It's refrigerant dependent, meaning that the headmaster is actually going to change, excuse me, from refrigerant to refrigerant, okay? Because there will be different valves depending on what type of refrigerant you're working on. On an old ARC-12 valve, you may see a headmaster that had a cut-in or a bypass temperature of or a pressure of 100 psi. Okay, but nowadays we see Headmaster valves, depending on what you're working on, that have bypass pressures of 150, 180, 210, 240. It just depends on what we're working on. You typically don't see above 240 unless you're working on an ice machine, or I should say above 210 unless you're working on an ice machine. Okay? But it is possible that you would have a Headmaster on a 410A system on a built-up air conditioning system. And I haven't worked on one of those, but I imagine that your pressures would be much higher than 140 psi. You'd have a very high pressure at which the Headmaster is going to bypass. Okay. So the point of the Headmaster, let's just make it simple, is that it's to maintain a pressure differential, constant pressure differential across your expansion valve. Okay. We can simplify it by saying it's to maintain head pressure, but you do need to understand that that's the whole point of having a Headmaster on the system, is to maintain that pressure differential across your expansion valve. Okay. So the thing that I got the most, and I always get this question, is how, well, number one, you get how do you diagnose a Headmaster? Okay, but the number one question I get is how do you charge a system with refrigerant that has a Headmaster? Okay, and that it can be kind of tricky. Now, in the video that I just released, I did show you guys my method of checking a system's refrigerant charge, okay, and charging a system. I do want to preface that, and I may have mentioned it in the video, or I know I've mentioned it in other videos, is that you always want to know how to do something the right way. My way is kind of a shortcut, and it's not the absolute correct way to do it, okay? What I would suggest you guys do, I'm going to go ahead and share my screen with you guys right now, and I'm going to show you a document. There's actually 3 documents that I want you guys to look up, and you should print these out and have them in your truck, and they're Sporlin documents. The first one is going to be, let me adjust this so you guys can see this here. Okay, and I'm going to go ahead and turn the screen share on. Hang on just a second, if I can figure out. This is where I get really screwy because I am not the smartest person in the world. No, cancel that, and let me log out of here. There we go, right there. Sorry about that, guys. Okay, so what we're going to do is I'm going to screen share. What I would suggest you guys do is go to Sporlin's website. Let's see if this pops up on YouTube. I thought this was going to pop up on YouTube, but I don't know if it's going to be honest with you. Yeah, I don't think it's going to. I apologize, guys. That's not going to work out the way that I wanted to. So what I want you guys to do is Google search Sporlin document 90-30-1. Okay, Sporlin document 90-30-1. Inside this document, what it's going to do is it's going to give you Sporlin's method of properly figuring out how much refrigerant we need for that system to operate properly when it has a head pressure control valve or a Headmaster. Okay. What it does is it essentially is going to have you measure out the total equivalent length of the condenser tubes, and it's going to let you figure out the internal volume of refrigerant that that condenser can hold. And you're going to do a math calculation to find out a totally flooded condenser, how much refrigerant that would be. So essentially, it's going to measure the lines. It's going to find out how much volume it can hold, and it's going to tell you that number. Then you're going to find out the characteristics of the refrigerant you're using, and it's going to tell you how much refrigerant you need to add to that condenser to have it fully flooded. Okay. Now, it's important to understand that in that document, again, Sporlin 90-30-1, you need to understand that once you have cleared your sight glass on your system, again, this is assuming the system has a refrigerant receiver, because most built-up systems do that have an expansion valve. You're only going to see a Headmaster on a system that has has a receiver anyways, okay? But what we need to do is we need to flood that condenser, and we need to make sure that we have a liquid seal inside that receiver, constantly maintaining a clear, solid column of liquid going to your expansion valve. Okay, so essentially what the valve is going to do is it's going to bypass the condenser. That is in a nutshell. Okay, that's not the exact thing that it does. It's actually going to meter the refrigerant. It's going to open and close the valve dependent on the pressures in the system. But to understand it the best way is it's going to shut off the refrigerant flow coming out of the condenser. It's going to back up the refrigerant, the liquid refrigerant in the condenser. But then it's also going to take the discharge refrigerant from the compressor, directly from the compressor, and it's going to feed it into the receiver. Now, one would think, though, if you had a discharge gas coming out of the compressor feeding directly into the receiver, you would have a problem because that discharge gas coming out of the compressor is not a liquid, right? It's high pressure, high temperature, superheated vapor, right? So that refrigerant, if was fed directly down to your expansion valve, would be a problem, right? Because your expansion valve would be getting vapor going to it. Well, this is where charging for a headmaster comes into play. Because when we flood that condenser with liquid, okay, and we shut off the flow coming out of it, we need to have what we call a winter charge sitting in that receiver, okay, creating a liquid seal in the bottom of that receiver. And I wish my screen share would work, but it's just not going to because I would show you guys a picture. But you need to understand that that receiver, the way a receiver works is it actually has a dip tube that runs to the bottom of the receiver and it pulls the refrigerant from the dip tube going down the liquid line to the expansion valve. Okay, so it's very important that the entire time that headmaster is bypassing, that the refrigerant level inside that receiver, the liquid level, stays above where the dip tube is going to pull the refrigerant. Okay, because that dip tube basically needs to pull liquid from that receiver. Okay, so what we need to do is, well, let's assume that we've got a properly charged system. So then now our condenser has bypassed. Okay, we filled it up with liquid refrigerant, but we still have a liquid seal inside that receiver. And we are now feeding still liquid refrigerant down to your expansion valve. Okay, keep in mind the way that that headmaster is going to work is that headmaster has a dome on the top of it. It has a constant pressure in it. That's let's just say it's 180 psi. Okay, so anytime system pressure drops below 180 psi, the refrigerant, the headmaster is going to adjust itself basically, and it's going to close off the refrigerant flow. Okay, and start allowing or stop allowing the liquid refrigerant coming out of the condenser basically. Okay, so anytime system pressure climbs above 180 psi, the refrigerant inside the headmaster is going to push that headmaster back open and it's going to maintain its normal flow of refrigerant, okay, which is the basic refrigeration cycle. I don't think I need to go through this, but pumps out of the compressor into the condenser, comes out of the condenser as a liquid, goes down to your metering device, okay? So that's the normal flow, right? When it bypasses, what it does is it shuts off the flow coming out of the condenser, and then it takes that discharge vapor from the compressor directly into the receiver, okay? But like I explained, that receiver should have a liquid seal in it or enough liquid to make sure that that dip tube is still pulling from the bottom of the receiver and it's pushing liquid down. So you're still going to have high pressure pushing into that receiver, but you're going to have enough liquid in the system to still feed liquid down to our expansion valve. And that system is going to run that way until the head pressure in the system climbs high enough to stop that valve from bypassing, then the system is going to go back into normal operation. Now, if we follow that Sporlan document that I told you about, Sporlan 90-30-1, okay, it's going to tell you how to properly calculate the flooded charge for that condenser. All right. Now, sometimes I find that not to be too practical. And it's hard for me to give you a perfect example, but there's sometimes in the system that it's hard for me to know exactly how much refrigerant is still left in the system. So let's say we have a refrigerant leak wherever it's at, and half of the refrigerant charge is leaked out, okay? It's difficult for me to know exactly how much of that refrigerant charge has leaked out. We could talk about that for a while, but that's kind of a difficult thing. So I did show a shortcut on how my method of checking refrigerant charge in the system is, okay? And it's based off of the theory that everything in your system is sized correctly. And this is very, very important. If your refrigerant receiver, your liquid line receiver, is not sized correctly, okay, you will not be able to pump it down or shut off the valve coming out of the receiver at the receiver, okay? If it's too small, then when you try to pump it down, the system's going to go off on high head pressure. If it was designed properly, your liquid line receiver would be able to be shut off at the valve, and all the system's refrigerant would stop at the receiver and just build up inside the receiver and build up inside the condenser, and there would be plenty of room and the head pressure would not climb. That's if the system is sized correctly. It's very important to understand that your system has to be sized correctly. Anytime there's a headmaster involved, your system has to be sized correctly. I bring this up because I run across problems where refrigeration manufacturers don't size their equipment appropriately, and someone goes and installs it in a shopping mall where it has a 150-foot liquid line, and then now we don't have enough storage capacity in the receiver. Okay, so again, another podcast. I don't want to go off on too much of a tangent, but it's very important to understand that your system has to be sized correctly for the headmaster to work properly and for you to be able to pump it down at the receiver. Okay, now, so assuming that the receiver is sized correctly, what I'm going to do is I'm going to shut off the refrigerant flow coming out of the receiver, and I'm going to pump that system down. All the refrigerant is going to back up inside that receiver, and I'm going to do that until the low pressure control turns off the compressor. Okay, once the low pressure control has turned off the compressor, you may have to give it 2 times for it to cycle because your pressure may build back up. Let it cycle. Then what I'm going to do is, and you have to be very, very careful about this, okay? I am going to take a heat source, okay? Something that does not get above the temperature, the safety temperature of your receiver. Your receiver has something on it called a soft plug, okay? The soft plug is usually a small piece of low temperature solder somewhere on there that has a blowout pressure of like 400 degrees. Okay, so if that receiver's internal temperature ever got above 400 degrees, or the surface temperature, and it got to the point of that soft plug or that low temperature solder, it would blow that low temperature solder out and vent all the refrigerant before the receiver exploded and blew shrapnel everywhere. Okay, so it's very important to understand and know where the soft plug is on the receiver. If you could somehow find that soft plug and somehow know what the temperature of that soft plug, the relief temperature, is, what you could theoretically do is take a heat source when the receiver is pumped down, wave it once or twice up and down the receiver, then take the heat source off. That heat source, again, cannot get above 400 degrees, okay, or whatever the soft plug temperature is. Once you've removed that heat source, you can then take your fingers and run them, starting at the bottom of the receiver, up until you start to feel a temperature change. Okay, you're going to go from bottom to top, and you'll see it in my video. I went from bottom to top, and I found the point at which the temperature in that receiver got red hot. What that meant was that was the end of my liquid level in that receiver. So this is a crude way of telling me where the liquid line is in that receiver. Okay, so I took that heat source, I went up and down the receiver, and again, it was pumped down. And again, that heat source did not get above 400 degrees or whatever the soft plug blowout temperature was. Okay, you have to understand what that is. And I took that heat source and I waved my fingers up and down, and then I found the point. And I think in the video, the first time I did it, the point at which I found the heat was like, a quarter of the receiver or a third of the receiver. Now, what I'm doing with this method is, because I didn't know how much refrigerant had been lost out of the system, okay, what I'm going to do is I'm going to put the maximum amount of refrigerant in the system. Now, this is not necessarily the correct way, but this is kind of a shortcut, okay? Again, I've mentioned in my videos, if you're going to take a shortcut, you better be ready for the repercussions, and you better be ready to know what could go wrong and what might go wrong. Okay, but assuming that we never get that receiver's temperature above the soft plug blowout point, then we're safe. Okay, so the theory here is that I'm going to put the maximum amount of refrigerant that I can possibly put in this system. Okay, the maximum amount of refrigerant in this system that I ever want to fill that receiver is about 90% full, 80 to 90%. Okay, you never ever want to fill that refrigerant receiver with more than 80. Let's just call it 80% of refrigerant. Okay, that receiver needs to have room for the refrigerant to expand. Okay, if you filled it 100% with liquid, then you would have a problem. Okay, because that refrigerant changes state, so it changes from a vapor to a liquid, and when that happens, we can raise our pressure of our refrigerant. Okay, so we need to make sure that we never ever fill that receiver over 80%. So what I can do is I can feel the liquid level. And when I started it, I knew that the liquid level was at about a third. Let's just say it was a third. And I needed to put the maximum amount of refrigerant I could put in that system. Okay. So what I did was I filled that refrigerant with liquid refrigerant until I got to the 80% mark. Okay. I just call it 75, just the 3/4 mark is usually where it's at. Now, something to understand, had I been able to use the Sporlin method, the 90-30-1, which is the way that I suggest you do it, but had I been able to do that, more than likely, our receiver level, when it was pumped down, would not have been at 80%. Okay, that is something you have to take into consideration too. How much is the difference between the calculated refrigerant level and the maximum capacity of the system? We're talking 20, 30 pounds, you may want to reconsider using my method because we don't ever want to put so much refrigerant that we're charging the customer extra money. Okay. But I'm not going to go too crazy into this, but if we use Sporlin's method, which there's nothing wrong with Sporlin's method, what I would suggest you do, if you do use their method, that's the right way to do it. I would suggest you go ahead and do a pump down test on this receiver and you mark the liquid level. Okay, if you mark the liquid level, then you could still do my test where you warm up the receiver, feel the temperature rise across the receiver, and then you could just know where the proper refrigerant charge is at, and then you wouldn't have to fill the receiver up to the maximum capacity. So my method of warming up the receiver with some sort of heat device, still works for using Sporlin's method too. You would still calculate the charge, use their method, and then just mark the level of the receiver. And then from that point forward, if you ever have a leak again, you just fill it up to that mark, and you know that that's the calculated amount to fill that receiver up to. Okay. But because I couldn't do that in my situation, what I did was I went ahead and filled that receiver up 80%. Okay, or the 3/4 mark of the receiver. And I basically did it. I put more refrigerant in it. I started at a third and I added refrigerant until I got to the 3/4 mark. And I knew that I had the maximum amount of refrigerant in that system and the system would operate properly. Okay. Now, I would highly suggest that you guys look at that document that I mentioned, the 90-30-1. Sporlin also has two more documents concerning head pressure control valves or low ambient controls. Okay. Those other documents are Sporlin 90-30. You can just Google search these and they'll come right up. Okay. So Sporlin 90-30 and also Sporlin 90-198. Okay. So if you look up those two documents, you will find all kinds of information. I should say three documents. Okay. So Sporlin 90-198 talks about the fundamentals of a head pressure control. Okay. About what it does for you and why you use it. Okay. It goes in a lot more in depth than to what I was talking about. Okay. And if you go to Sporlin 90-30, it's going to talk about head pressure control valves in general, not just low ambient controls. Okay. And define them and explain them a little bit more. And then 90-30-1 is how to charge the system. Again, what you're going to do is you're going to measure the total equivalent length of the condenser tubes. You're going to find out the total flooded charge, how much refrigerant it would take to fill that condenser up and flood it completely, or flood it to whatever level you need to flood it to maintain proper head pressure. It is also important to understand that in Sporlin's 90-30-1 document, it is going to explain to you and help you to figure out how much of your condenser you actually need to flood. Because depending on your lowest ambient temperature of the year, you may not need to flood that condenser as much as someone in Minnesota might have to. Here in Southern California, my absolute coldest temperature, and I know most of you guys are going to hate me for this, but my absolute coldest temperature that I've ever seen where I live is 30 degrees. Okay? And that is extreme. It probably didn't maintain that for more than 6 hours. Okay. On average, during the winter time, we maintain 65 degrees. We might have a low in the 50s, but it doesn't get very cold here. Okay. But we still do run into headmaster valves and we still need them for low ambient control. Because anytime you drop theoretically below 70 degrees, you really should have, for a constant long period of time, you really should have some kind of a low ambient control to help you to maintain that pressure differential across your expansion valve. Okay. So what are some things that if you are not maintaining that pressure differential across that expansion valve, what can happen is that expansion valve can start to act erratically. It won't work correctly. Okay, it may not maintain superheat. You potentially could run really high superheat. You could cause all kinds of problems in the system. So it's important that we maintain that constant pressure differential across across that expansion valve. Okay. Now, when you start to get into the newer systems that have electronically controlled expansion valves, it's very interesting to know that they're able to widen the pressure differential across the valve because the valve has better control of the superheat, basically. Okay, as Brian Orr says, our expansion valve is a constant superheat valve. Okay, so the whole point of the expansion valve is to maintain a constant superheat, right? So, but when you get into the electronic expansion valves or electronically controlled expansion valves, what you'll start to see is headmasters that have a much lower cut-in pressure or bypass pressure that allows them to get the condensing temperature a lot cooler. That way, to try to get more energy efficiency out of the system. And we're not going to go crazy into that right now. Okay, so it's really, really important. I want you guys to understand that in my video, I did show you a shortcut. It is not necessarily the right way to do it. It is a shortcut. You do have to know what you're doing when you use that shortcut, and always understand that if you do use a shortcut, be ready for the repercussions of said shortcut. Okay, that's my cover my ass disclaimer. All right. What I'm going to do, I'm going to look over here at the chat for a second. I'm sure you guys have got a lot of stuff going on here. I'm going to go ahead and kind of scroll back up here a little bit and see what we got going on in the comments here. All right. Okay. Very, very important. Something I want to point out. Someone pointed it out in the comments. Sometimes I assume that people understand exactly what I'm talking about and know what I'm saying. If you have an ice machine that has a remote condenser, I don't care if it's a Manitowoc cool vapor discharge system or CVD system. I don't care if it's a traditional remote system where you just have a condenser on the roof and the compressors downstairs. Anytime you have a remote condenser on an ice machine, okay, you will see a headmaster valve. It's very important to understand. The method that I told you about checking the liquid line or liquid level in a receiver, it does not apply to an ice machine. Okay, with an ice machine doesn't matter what brand it is, it's critically charged, meaning that you don't just add gas and move on. Okay, if I have an ice machine that has a refrigerant leak, there's no way of knowing how much refrigerant has leaked out of that system. We don't run sight glasses on them. They do have receivers sometimes, but we don't run sight glasses on them. Okay, because you can't charge by a sight glass on an ice machine. It's critically charged. If you do have a refrigerant leak, you have to recover all the charge, fix leak, and weigh the charge back in. Okay, there is methods of temporarily adding gas to an ice machine. A lot, the most, I think Hoshizaki says don't ever add more than 4 pounds, I think, at a time. But still, the right way to do it on an ice machine is always recover the charge, fix said leak, weigh in the charge. Okay, so you can't use this method on an ice machine at all. Okay, my shortcut method. My shortcut method is only going to work on a refrigeration system, a walk-in cooler, walk-in freezer, a built-up air conditioning system, or a reach-in cooler that has a remote condenser on the roof. Okay, so long as the receiver is adequately sized in the system. Okay, the reason why you will see a headmaster on an ice machine is that ice machines are all going to use some sort of a hot gas or a cool vapor discharge. Okay, with that being said, in order to use a hot gas, defrost, I should say. In order to do a hot gas defrost, we have to have a very, very small pressure swing essentially in the system. Okay, we have to maintain that head pressure. We have to have that hot discharge gas or that warm vapor coming off the top of the receiver, vice versa. The reason why I say cool vapor is if you know anything about Manitowoc's CVD ice machines, the cool vapor discharge, they use a different method. Instead of using hot gas to defrost the ice, they take cool vapor off the top of the receiver and they call it cool vapor, but it's just warm vapor off the top of the receiver and they melt the ice off that way. But even still, with a cool vapor defrost or a hot gas defrost, you need that head pressure to be high enough to melt that ice off. Okay, so you're always going to see a headmaster on an ice machine that has a remote condenser. Typically don't see them on the self-contained ice machines. I'm not going to say you never will, but you will see a hot gas defrost on a self-contained. But the fact that it's self-contained, they assume that it's going to be located in an ambient, that's above 70 degrees at all times. Okay, so very important. I'm going to go back over here to the comments again real quick. Okay. Prime time, you said headmaster valves are useless. Headmaster valves can be very frustrating. Okay. They can be hard to diagnose. Okay, there's all kinds of ways that they can fail. I can do a whole other video on that. Okay, but they can be very hard to diagnose, and it's very important that you understand how they work, because it does help you to understand how to diagnose them too. Okay, and yeah, I mean, they're a pain in the butt, but you know what? They're a necessary evil, especially when we have cold climates, to maintain our pressure differential across that expansion valve. There is other methods of doing head pressure control. Okay, we can also do fan cycling, where we shut off a condenser fan motor, or we can stage condenser fan motors. We do all kinds of stuff. Okay, there's goods and bads to both. Fan cycle controls tend to be a little hard on the system, meaning that they shut off, it drives your head pressure really high, really quick, and then they turn on, and then your head pressure drops really fast. On a headmaster valve, or it's a constant, a nice, slow, steady buildup. Nothing harsh, nothing crazy fast. It's just nice and slow. So I do like headmasters. I do think that they're good. I think that a lot of people have a hard time diagnosing them, and they do cause some problems. Okay, but it's very important to understand that you have to have the proper charge for a headmaster to work. Okay, so before I go back to the comments, let's go on this one too. It's really important to understand that a headmaster is very rarely going to be used in the summertime. Okay, so that's why that receiver needs to be sized correctly, because typically we're not going and removing refrigerant in the summertime and then putting it back in the wintertime. System should be sized correctly, that refrigerant can sit and be stored in that receiver all summer long, and it would only use what it needs to clear the sight glass, and the rest of it is just backed up in the receiver. Okay, when the headmaster is not bypassing. We tend to get a lot of service calls right now because it's cooler weather right now, and it's fall, so it's just starting to get cool. And what has happened is we've had a lot of extra refrigerant stored in that receiver all summer long. And so there's been a leak in it, let's just say, okay, but only a little bit has leaked out. Not enough, because we had an extra, let's say, 6 pounds of gas in there. So all summer long, it's been slowly leaking out that 6 pounds. And then right now, the first fall day, all of a sudden the pressure in the system drops low enough for that headmaster to bypass, and we don't have enough refrigerant in the system anymore. Okay. And the most common call I'm going to get right now is they're going to call me and say, hey, my walk-in cooler, when I first get there in the morning, my walk-in cooler is at 55 degrees and it's making this hissing sound inside. But then come 12:30 in the afternoon, it works fine. Then it runs great until the next morning, and then it stops working again. Okay. You may show up at 2 o'clock in the afternoon. You may walk up to the system and it's down to temp and everything's great. It's got a clear sight glass. Everybody's happy. But what's happening is, so in the summertime, or even when you're walking up and it's warmer outside, you may not notice that the system is low on refrigerant. And that's why it's important to mark your receiver level when you do figure out the correct charge, because you can always just pump it down real quick. If you suspect it's low on charge, you can check that receiver level. So let's say you went through Sporland's method and you found out the right way to charge it. You mark it, you feel it, and you say, hey, this thing had this much refrigerant in it, and you know where that level is. You can fill it up to there. Okay, so that's why it's important to make sure that this charge is correct, because come the time when it starts getting cooler outside, we're really going to start getting a lot more of these calls, because it's slowly been leaking all summer long, but it wasn't low enough to make the sight glass splash in the summertime. But now that we need that extra refrigerant to flood the condenser, that's when we're really going to start to see the refrigerant shortage make itself come into the light. Okay, I'm going to go down to the bottom and just kind of go down here. Familia Sanchez, thank you very much, dude. I really appreciate that. That was really nice of you. Andrew Jacks, I'm just going to work up from the bottom. Okay, I'm just going to go through your guys' comments. If you have any other questions or things you want me to point out or talk about, bring it into the comments right now, because I'm just going to read these and go through them. Okay, so yeah, so you added 6 pounds to your system to temporarily get it going, and you're going to go back and find the leak. That's something that I would do too. In fact, I had a technician on a service call a little while ago on a walk-in cooler, and the system was low on gas. He topped it off, and we'll go back there and figure out what's going on. Let's see. Randy, yeah, if a headmaster fails, Randy says that he's seen headmasters go bad and kill compressors. Um, I guess I could see that. So let's talk about a few different ways that a headmaster can fail, okay? Headmaster can fail in two ways. It opens or it doesn't open. I guess you can say three, or it gets stuck open, okay? Um, I guess that's two, really. Okay, what you'll get is in the summertime, you'll get a system that you'll go out there and the thing will be just going off on high head pressure constantly, and it's just going crazy if it has a head pressure control. Okay, let's assume that our systems all have head pressure safety controls on them because they need to if they don't. Okay, that is where a headmaster would kill a compressor in an instant, okay, because if it gets stuck open, okay, and it's bypassing the condenser in the summertime, we have a problem. We are going to go off on high head pressure instantly because there's nothing to reject the heat out of that refrigerant coming out of the compressor. So it'd be dumped right into your receiver and your system would instantly go off on high head pressure and or thermal overload and or catastrophic destruction of the discharge valve plate. Okay, so it's very important that your systems have functioning high pressure controls. Very, very important. I think that we don't test those enough. I mean, even I don't test a high pressure control enough. It's really simple just to disconnect the condenser fan motor, block off a condenser, and test a high pressure control. Just put your gauges on it, make sure it's set at 400, or whatever your refrigerant is. I'm thinking of 404 because we're going to set it about 450 typically, and watch it cut out at 450 psi. It's not something that you want to do every day, but we should probably be testing our high pressure cutouts. If we could. I mean, in a perfect world, if you could unscrew your high pressure cutout and put it on a bottle of nitrogen, that'd be the easiest way to test and see what it cuts in and cuts out at. But, we oftentimes can't get those high pressure controls off. So, but yes, I guess in that way, if you didn't have a high pressure control, a headmaster could kill a compressor easily. Let me also tell you that headmasters typically don't fail, okay, for just, any reason. I would guess if we had someone from Sportland on here that they would say the failure rate for headmasters, I would guess would be like 95% is people not using proper refrigeration practices, not brazing with nitrogen, not properly evacuating the system, not putting on liquid line filter dryers. Headmasters get stuck when things that are floating in the system get stuck in it and don't allow the valve to close. Same thing with expansion valves. Typically, expansion valves don't fail other than maybe a thermostatic element or a power head going bad, okay? But typically the internals of the valve usually don't fail, all right? You wouldn't even call the whole debacle with the rust inhibitor in the compressors, an expansion valve's fault. Yeah, the expansion valves were getting all gummed up, but it wasn't their fault that there was a contaminant in the system. Okay, so I would argue that a headmaster typically doesn't fail, and that if it does fail, majority of the time it's going to be because there's something floating around in that system, and someone before you didn't do their job properly. Isaiah, yeah, you are correct. Isaiah's AC kid, guys. Yeah, it's going to have. Yeah, I guess that's a way to say. The bucket just sits there and fills up, and the dip tube at the top of the receiver is drawing from the bottom of the bucket. Okay, and in the summertime, it's just going to sit there at three quarters of a bucket or half a bucket. But in the wintertime is when it's really going to start using that refrigerant. So it's important. I like your bucket analogy. That's a pretty good one, actually. It's important to know that in the summer or in the wintertime, when it starts to flood that condenser, that liquid level does not drop below the dip tube in the bottom of the receiver that's pulling from the bottom, because that dip tube needs to have that liquid refrigerant always feeding downstairs with the high pressure refrigerant pushing on top of it. So, um, Ryan Leary, 450 psi is a pretty darn normal pressure for us here in SoCal in the middle of the summer. This last summer, we broke a record for an entire day. We had 120-degree ambient temperature outside. I have a video on my channel about a walk-in freezer, and I don't know the name of it right now. Actually, I'll try to find it here so I can tell you, where I was on top of a shopping mall. And granted, it wasn't in the perfect environment. It was in a parking structure, but my head pressure in the system was 450 psi going off on high head pressure. And what was interesting, let's just even step out of that system. I had other systems that were outside in the outdoor ambient, running at 120 degrees ambient temperature. My head pressure in that 404A system was just through the roof. We were tripping head pressure controls. We couldn't go around to reset them fast enough. And there was nothing that we could do because nothing was wrong with the system other than it was being so hot outside. There was actually a couple videos that I did this summer where I was literally, and this is a horrible thing to do, but I was literally going around putting on misters on all my condensers in my area because there was nothing I could do. The compressors were going off on thermal overload left and right. Because yes, running at 450 psi was not good, but there was nothing wrong with the system. It was just too darn hot outside. The systems were sized right, the condensers were sized right, everything. It was just ridiculously hot. But yeah, we broke a record. We've never hit 120. It was literally at my house. It was 120. It was nuts, and it was for a solid day. And then later in the week, we did 117, 118, and even still, you're pushing 450 psi, no problem, man. Yeah, it's not good for the discharge valves of that compressor, but what can you do? You know, there's nothing you could do. The only thing I was doing to save the day was just putting misters on my condenser, and I'm seeing the repercussions of it now because those systems have calcium buildup all over the condensers now, and I mean the misters were on there for like two or 3 weeks straight because of the high temperatures we had. Like I would go turn it off, and then 2 days later I'd get called back out there. So I just got sick of going back and forth. So I just left them running. And yeah, that was a crazy. Was a crazy summer. We hit some high temps, man. It was nuts. And the 450 cutout, there was nothing you could do. If you put them at 400, man, you'd ruin that compressor. It'd be going off on thermal overload so fast. It was like you couldn't win because at 400 psi cutout, the compressor would short cycle almost because it would turn on, turn off, turn on, turn off. But then if you put it to 450, you know, it would run longer, but then the compressor would, you know, obviously start killing itself inside. It was just a brutal summer for us. And that I'd say normally we hit on an extreme high at 110, 115, but we actually hit 120. That was nuts. So yeah, I know the Colorado stuff, yeah, 350, yeah, that's an extreme, you know, there. But here, yeah, it was crazy. Cool. So do you guys have any other questions? There's a couple other things I want to talk about. Let me look at my little notes right here. It's important to understand what we call that liquid level in the receiver, okay, and understand how a receiver works. You guys can Google search a receiver. Just type in liquid line receiver dip tube, and it'll show you guys what the inside of a receiver looks like. It's not just a vessel. It has the outlet of the receiver has a dip tube coming in and going up typically about an inch or two from the bottom of the receiver. So it draws from the bottom of the receiver. So it doesn't just draw, you know, push refrigerant in and push refrigerant out. It actually pushes refrigerant in, but then draws that refrigerant from the bottom of the receiver. So it's very important to make sure that we have that liquid seal inside there at all times. Yeah, I would really strongly suggest you guys Google search those Sporland documents. I would also suggest that you guys look up Heatcraft refrigeration. It's Heatcraft RPD Ralph Paul Dom rpd.com. Sorry. And go to their literature tab. If you look up Heatcraft refrigerant and go to literature, it's right on the top. Go to miscellaneous. There's some good information there. I'm going to tell you guys something that Sporland's method, the 90-30-1, 90-30, and the form 90-198. I should say 90-30-1. The methods that they give you will only work on a tube and fin condenser. Okay, tube and fin is a standard copper tube with aluminum fins on it. It will not work on a microchannel condenser. Okay, because microchannel uses a different method, okay, of refrigerant. It doesn't use copper lines. This is kind of a gray area because the manufacturers don't tell you how to check the liquid or how to properly charge a microchannel condenser when you're using microchannels. Heatcraft has recently gone to microchannel condensers for all their little refrigeration condensing units. And with the Heatcraft condensing units, you can't use that Sporland method that's outlined in 90-30-1 document, okay? So you have two ways of doing it. You can follow Heatcraft's document that they have. You guys could just Google search it. Google search Heatcraft H-HTSQA-PKG, or you can just go to heatcraftrpd.com, look up literature, and just scroll through the documents and you'll see it. But this is how to properly charge a microchannel condenser. And what they tell you to do is just weigh in a certain charge after you've cleared the sight glass above a 70-degree outdoor ambient. And the difficult thing about that is their method tells you how much extra refrigerant to add per condensing unit. Okay, so on this particular, I'm looking at the chart right now. I wish I could show you guys my thing, but it doesn't let me. But on this particular sheet right now, an 040X6 condensing unit, I'm going to add an extra 1.25 pounds to compensate for the Headmaster to that system. But the problem is that I go out there and I find out that the system has a leak. How much has leaked out of that 1.25 pounds? That I don't know. So that's why I use my method to find the liquid level in the receiver and put the maximum amount in there, because it makes it difficult to find out exactly how much of the winter charge is already leaked out. Okay, so that's where I fill that receiver up to 90% and call it a day, because I know I can't put any more refrigerant in that system safely. Okay. So yeah, go to heatcraftrpd.com. You'll find under literature, you can Google, you can look up, it says 1/2-6 horsepower air-cooled condensing unit with hypercore microchannel coil technology, frequently asked questions. Click on that and it'll show you their method of figuring out. That's for Heatcraft only. That doesn't apply to any other manufacturer that's using a microchannel refrigeration condenser. Okay. Let me keep seeing. Okay, there is methods of doing things like cooling down the condenser with cold water. Seeing people do it. Not saying it's not going to work. I guess it would work. Okay, but it's kind of like I just don't use that method, so I really don't know what kind of problems I could potentially run into. I've always been told that if you run cold water across a condenser, that you can actually put way too much refrigerant in it. But I guess if you pumped down your liquid line receiver after you added that refrigerant, okay, then yeah, I guess that would work, as long as you know the liquid line receiver doesn't have too much refrigerant. Let me step back a little bit. Let's make a point here that I haven't made yet that I probably should have made. If we're working on a refrigeration system that has an expansion valve and a liquid line receiver, okay, we're not going to use superheat and subcooling to charge this system. Let's make that clear right now. You're not going to, subcooling is going to go out the door. Okay. Subcooling is an indication of problems, but subcooling is not a method to charge, okay, on a refrigeration system with a liquid line receiver. With a liquid line receiver, we are going to use a sight glass. Bottom line. Okay. That sight glass needs to be clear when the system is almost at temperature. Okay. You do not leave bubbles in the sight glass. You do not ignore a sight glass. A sight glass on a refrigeration system, liquid line indicator, is there to tell us if there's liquid in the system. Now, I will be careful, and I will, tell you that a sight glass can also be used as a moisture indicator on an air conditioning system, a non-built-up air conditioning system, and that could, you don't want to charge by a sight glass on an air conditioning system that doesn't have a receiver. Okay, but if you have a receiver on your system and it has a sight glass, that sight glass will be clear when it's operating properly. Okay, you do have to clear that sight glass. Okay, and that's the whole point of the liquid level inside the receiver, is to ensure that we have a clear, solid column of liquid going to our expansion valve. Your expansion valve accepts liquid on one side and sends a vapor liquid mixture out on the other side. Okay, it does not accept vapor on one side of that expansion valve. It has to have a liquid, solid column of liquid going to that expansion valve for it to work correctly. Okay, there's a lot of variables in our system, but I really didn't go into the refrigeration cycle here. I'm just talking about how to properly charge the system with the Headmaster. All right. Another thing that I will preface is, if you walk up to a refrigeration system that has a sight glass on it and it's cold outside and that sight glass is flashing, that tells you that that system is low on charge. But you do want to make sure that the system is not currently pumping down. okay, and that it is not iced up. Okay, these are, I'm not going into this because I'm not teaching you guys basic refrigeration. We're just talking about a headmaster, so I'm assuming that you guys understand how these things work. You know, you don't go adding charge to anything until you make sure that it has proper airflow, it's not iced up, and you know, once you've done those two things, then you can start adjusting your refrigerant charge. Do not ever, ever, ever adjust refrigerant charge without putting your high side and your low side gauges on the system. Do not just charge with your load side on there. Okay, that doesn't do anything for you because you need to know what's going on the high side of your system too. Okay, but again, this is going into basic stuff. We don't need to go crazy with that right now. So I'm going to just scroll through the comments here again real quick. Dave, okay, you make a good point. He says, with a larger system, say 10 plus pounds, and a leak with blended refrigerant, say 404, it's better to recover and start over. Yes and no. 404, okay, some people have talked about refrigerant fractionation in the past, okay? Fractionating is when the refrigerants inside of a refrigerant separate, okay? If you don't understand, I'm not a genius when it comes to this stuff, okay? But I'm just going to give you guys my 10 cents on it, okay? Refrigeration system or refrigerant that any of the refrigerants right now, yeah, I think almost all the refrigerants. No, not the R22, but all of your blends. Okay, they're going to be a mixture of multiple refrigerants, and at different temperatures, those refrigerants can boil off. Okay, so there is something that can happen is fractionation in your refrigerant, and it has in the beginning. It was really stressed, just like the whole don't mix POE and mineral oil. In the beginning, it was stressed that if you mix a drop of mineral and a drop of POE, that it would be the end of the world. Okay, and we've since learned that it does. It's not good, but it's not the end of the world if you get a little bit of mixture in there. Okay, so we've kind of calmed down on that one. The same thing goes with the fractionation. That is not of all refrigerants, but 404 doesn't fractionate easily. It takes some time. I'm not saying that if it leaked out 10 pounds of a 20-pound charge that it would be right if you just topped off the charge, but I have done it and it works fine. Okay. 404 doesn't fractionate very easily, as easily as some other gases. Okay. So, you know, you kind of got to make a judgment call on that one. I would probably, you know, if someone called me and said, dude, this thing's leaked out 3/4 of the charge, what do I do? I would probably advise them to go ahead and recover the whole charge and start over. Yes, that would be a good, safe way of doing it. But I will tell you that refrigerant leaks with 404, it's not the end of the world. I would say once you get past the halfway mark is when you need to start getting scared, half charge. Okay. Again, I know it's hard to understand exactly how much refrigerant your walk-in cooler might have, but you can kind of start to understand. If you look up part numbers from receivers, you can know that that particular receiver has a 10-pound pump down capacity. So, you know, if you had to add 5 pounds, then yeah, you know, you may want to talk to someone about changing out that refrigerant. But in a perfect world, I would say when you go to make the repair, go ahead and change the refrigerant out just to save face. But you know, if I'm going to get them going temporarily, I'm probably just going to top off the charge with 404. That does not apply to other refrigerants. Okay, that's my experience with it. I know that I've heard a lot, or some people that are much smarter than me tell me that exact fact that the fractionation rate of 404 is very low. But you know, that's just something that I heard. Um, let's see. I'm reading your guys' comments here. Um, Going through here, I'm seeing if there's any questions that I haven't answered or anything in here, guys. So if you have anything that you did in the back, I'm gonna put it down in the bottom of the comments again. So um, I'm just kind of going back up, seeing if I missed anything from you guys here. Seeing if I missed. I think this is kind of about all that I want to cover here. Past 35 degrees to 4 is a little quieter. I'm not seeing any other questions, man. Guys, I don't know if these questions are meant towards me. I think you guys are having a conversation in here because you're asking what company someone works for. for HVAC apprentice, total tech, you're asking that. I'm assuming you're asking that to other people. Guys, I'm not, some of you have asked me the name of my company. I prefer to keep that private just because there's some jackasses on YouTube that you'd be surprised. I get some people that are jackasses. Let's just say that. Okay. So I try to keep my company name out of the limelight. I would appreciate, some of you guys do know my company name. I'd appreciate you guys keeping it on the down low if possible. Okay. It's not that I'm doing anything wrong at all. I know that I don't do anything wrong in my videos, but I just like to keep the public eye off of my company if at all possible. So, is Trenton using microchannel? I don't think Trenton is using microchannel, but I haven't seen a new Trenton in a while. I haven't installed a Trenton in over 10 years. So I don't know if they're using it yet. Burn the world. Yeah, that's kind of my thing too. You know, uh, I think the fractionation was just, it does exist. Don't get me wrong, but I think it was kind of overhyped a little bit. So, um, Andrew Jacks, that is a great question, and I have yet to get a thermal imager. Andrew Jacks asks if you can see the liquid level with a thermal camera. I have been wanting a thermal imager so bad for a while, and I just haven't been able to justify the cost for a not cheapo one. I really think that a thermal imager could do a great job. I bet you anything that you wouldn't even have to use a heat up the receiver. I bet you that with the thermal imager, if it's a good one, you could probably see the liquid level of that receiver pumped down without even heating it up. So that's a really good question, and I have just yet to buy a thermal imager, but that's on my list of wish list items. If I had a company that wanted me to pay to test a thermal imager, I'd be on that one because I want to try one out. I'd really like to try someone's, or if any of you guys have ever used a thermal imager, let me know. So, Rick, so you have been able to see the level with the thermal imaging camera? Now, did you have to heat up the receiver, or did you just pump it down? I'm curious. Yeah, I've been wanting a thermal imager, so let's see. I really would like to get one and try it out. Thanks, Alexander. Um, you guys, if you haven't already, Rick is in here right now. He has a YouTube channel called Northwest Ohio HVAC Videos. He makes great videos, and his subscriber count has been slowly rising, but you guys need to get it up. So if you guys haven't already, go over to his channel and subscribe to it. I promise that you guys will appreciate his content. He does great work on there, so give him a shot. There's a couple other people making YouTube videos in here, guys. Alexander's refrigeration and HVAC videos. Alexander in Puerto Rico makes videos. You have Isaiah. I saw you in here earlier with the AC Kid, and then you have the other Isaiah. Where are you at, Isaiah? With HVAC with the ZSAS. Okay, look up that YouTube channel too. Great content on there, you guys. If you haven't already subscribed to those ones. Let's see. Let's just go over this real quick since I'm already talking about them. Let's go to these other channels that I recommend, and I'll tell you guys here because there's some good ones on here, and I'd really like you guys to give some of these guys some subscriptions if you guys haven't already. 404 Refrigeration has one. You guys check out his channel. Obviously, Andrew Greaves has got a great channel, AKHVAC. There's so many of them, guys. My buddy Chris Cassie at CSC Refrigeration and HVAC. He makes some good videos too. You guys, there's all kinds of people out there. Familia Sanchez, I know you were in here. You've got some good videos on there. So there's a bunch of people in here. So if you guys, the people that are in here, if you guys just click on their little avatars, you'll see their YouTube channels, and you guys can subscribe to those. I think that'd be good if you guys did that for them. So I'm gonna scroll down here. Let's see. Yeah, NorCal Dave has great content. NorCal Dave makes great videos. He was one of the ones that really got me interested in YouTube. So, Alpha Tech, that's the same thing for me too. I'd like to know if anybody's used a thermal imaging camera like the $400 one, like the FLIR one, or the Seek, because those are the cheaper low end ones, and I just want to know if it's worth the cost. If I could buy it from a store. I've contemplated buying one from Amazon, and then if it didn't work, just returning it. I guess I should probably try that and test it out. You know. Um, So let's see, that'd be interested to see if anybody has used a thermal imager. So who in the comments here has said they've used a thermal imager to see liquid level? Rick, I know you said you did, right? Has anybody else used one? I don't know if the chat's behind because I don't see it very fast. So I think it is a little bit behind what I'm talking. So wait for someone to make a comment and I'm just sitting here with dead air. Okay. You guys, I think I'm going to start wrapping this up. Yeah, it's been about an hour. So let's go ahead and wrap this up. I really appreciate you guys taking the time to watch this and coming into this live stream. You guys send me more questions, send me more feedback. There's some stuff in the works. I'd like to know what your guys' thoughts are on a refrigeration podcast. I don't know if I don't know if I feel comfortable enough doing it by myself. I might need some people's help if anybody would possibly be interested in that. So that's something that I'm thinking about in the works. I've also started emailing some manufacturers about possible giveaways. So let's see, that might be in the works too. Let's get some feedback from some people. I sent out a bunch of emails and I got like 2 responses back. So we'll see. We'll see what they end up doing. I'm reading the comments too here, guys. So he said, yeah, guys. You guys, the fan cycle control works. Don't get me wrong. It's a little more rough on the system, and a Headmaster is a little bit more gentle and smooth, in my opinion. Okay, and I've heard that same thing. So, okay, yeah. So yeah, guys, I really appreciate you guys taking taking the time to watch this. And Isaiah HVAC with ZSA, guys, he's got a giveaway for an S-Man 460, I think. Check out his channel. He's still taking entries for it, so he's going to give it away just randomly. If someone out there needs a new manifold, go subscribe to his channel and follow the rules of the contest. So, but yeah, so we're thinking about maybe doing a podcast. I might need some help. Let me know if anybody's interested. If anybody would like to be a guest, that kind of stuff. Yeah, and that's pretty much it. I have some ideas for podcasts, but I know that I can't consistently upload every single day. But we could possibly do something there. So, okay, all right, guys. Well, I'm gonna go ahead and sign this off. Have a good night, guys. Thanks a lot for coming on here, and we'll see you guys next time. Okay. All right.